Hello friends, in this video I'd like to solve the following problem from the Romanian District Mathematical Olympiad for 10th graders 2017, problem number 3. Let a be a positive real number. We wish to prove the following inequality. A to the power sine of theta times 1 plus a to the power cosine of theta is strictly greater than a for all angles between 0 and pi over 2. I have slightly modified this problem in the original problem statement. In this place there was weak inequality and in this place as well, but I think that my formulation is strictly maybe more general, because it's easy to verify what happens in this case when theta equals pi over 2. Here are my hints for this problem. First, consider first a from 0 open to 1 closed. Pretty easy to see what happens in this case. But for a equals 1, problem becomes much more interesting. Take natural log on both sides and differentiate this function which we will get. And also, our function is differentiable. It is defined over a compact interval from 0 closed to pi over 2 closed. So, this function can attain its minimum either at 0 or at pi over 2, or at any point at which the derivative vanishes. And finally, well, what happens at pi over 2 and 0 is not hard to verify, but show that there is exactly one angle theta sub 0 between 0 and pi over 2 for which our derivative is 0. Moreover, show that theta 0 is less than pi over 4, and then try to make some estimates to show that our function f evaluated at theta 0 is strictly greater than 0. And since the minimum is greater than 0, well, our function is also greater than 0 on the whole interval. So give this problem a try, and I will see you in just a minute. Alright, so you know what, let's start with taking natural log on both sides. So this inequality is equivalent, after taking natural log, to saying that that sine of theta times natural log of a plus cosine of theta times natural log of 1 plus a is greater than natural log of a, or equivalently, we can write that cosine of theta natural log of 1 plus a minus 1 minus sine of theta times natural log of a is strictly greater than 0. And let's define a function. So let f be a function going from 0 to pi over 2 into the set of real numbers. And we define it by the following formula. F of theta, well, it's just our function. Now, let's consider two cases. First case is easy. Case number 1, when our parameter a is between 0 and 1. Case number 1, when a is between 0 and less than or equal 1. What happens then? Let's take a look. Then let's take a look. Let's copy this formula and let's take a look. Notice that then cosine of theta is greater than 0 because our angle is from 0 to pi over 2. So it's greater than 0 for theta between 0 closed and pi over 2. Let's be exact. Well, there is natural log of 1 plus something positive, so it's again greater than 0. 1 minus sine of theta is greater than or equal 0. Or actually, it's also, let's write greater than or equal 0. And now, natural log of a, since a is from 0 to 1, this is less than 0 or equal. But here we have minus as well, so it also becomes positive. So we have sum of two positive numbers, or rather of one positive number and one non-negative. So the whole result is of course greater than 0. So it ends the first case. Case number 2 is not so straightforward. When a is strictly greater than 1, what then? Then, let's investigate the derivative of our function. F prime of theta equals, well, equals what exactly? The derivative of cosine is minus sine. And then we have minus 1 natural log of a, it's a constant, so it vanishes. But we have plus sine of theta, derivative of sine is cosine. Alright, and now let's investigate when is this derivative 0. F prime of theta equals 0 if and only if sine of theta natural log of 1 plus a equals cosine of theta natural log of a. And notice that this is equivalent. We can safely divide by cosine. So tangent of theta equals natural log of a over natural log of 1 plus. We can divide by cosine because at pi over 2, well, the right-hand side vanishes, but the left-hand side does not, so nothing is lost. Now, let's estimate the right-hand side. Notice that the number on the right-hand side is positive, because we are assuming that a is greater than 1. And it is also less than 1. Less than 1, why is that? Well, because obviously the numerator is less than the denominator. So, notice that this means that there is exactly one angle somewhere between 0 and pi over 4, which equals this thing. So, this implies that there is exactly one theta 0 between 0 and pi over 2, such that f prime of theta 0 equals 0. Moreover, this theta 0 is less than pi over 4. Pi over 4. All right. Now, let's investigate. So we have only 3 points to check. We have to check what happens with our function at boundaries of our interval and what happens at this angle theta 0. So maybe let's write it for the sake of clarity. So the minimum of f can be attained only at 0, theta 0, and at pi over 2. For these 3 points. So let's investigate it. Let's start with f of 0. Well, what is f of 0? Let's go back to our function. You know what? I will copy it. F of 0 is just natural log of 1 plus a. Yes, minus natural log of a. So it's natural log of, well, it's obviously greater than 0, because natural log of 1 plus a is strictly greater than natural log of a. All right. What happens at pi over 2? Well, if we have pi over 2, then we have, well, 0, since this disappears and this is 1. All right. And finally, what happens at theta 0? So we have cosine of theta 0, natural log of 1 plus a, minus 1 minus sine of theta 0, natural log of a. Let's investigate. Well, first of all, let's go back a little, or maybe let's not. So let's write it like in the following manner. Let's leave cosine as it is. But here I will do trick with this sine, because sine can be written as cosine of theta 0 times tangent of theta 0. So we have cosine of theta 0, natural log of 1 plus a. What is tangent of theta 0? Let's go back. Tangent of theta 0 is natural log of a over natural log of 1 plus a. Times cosine of theta 0 times natural log of a. Now let's clean it a little bit. So we can put 1 over natural log of 1 plus a in front. And we have what? Cosine of theta 0, natural log squared of 1 plus a. What then? We have minus natural log of a, natural log of a plus 1, or 1 plus a, plus cosine of theta 0 times natural log of a squared. Or rather, natural log squared of a. And maybe, you know what, I will, or maybe not. Now, time for some estimates. Notice that this is greater than 0. This is greater than 0 as well. So, and also remember that our angle is between 0 and pi over 4. And for angles between 0 and pi over 4, cosine of theta 0 is definitely greater than square root of 2 over 2. Likewise, this is also greater than square root of 2 over 2. So we have this. And of course, 1 over natural log of a is positive. So we have the following estimate. It's strictly greater than cosine of, no, not cosine, but square root of 2 over 2 times natural log squared of 1 plus a minus natural log of a, natural log of 1 plus a, plus square root of 2 over 2, natural log squared of a. Alright. Now, let's do some further estimates. We can write this expression, we can take 1 over square root of 2 in front, and we are left with natural log squared of 1 plus a minus square root of 2 natural log of a, natural log of 1 plus a, plus natural log squared of a. Perfect. Now, one more estimate. Notice that this number right here is again positive, so we are subtracting square root of 2 times something. Well, square root of 2 is obviously less than 2. So, we'll get this inequality if we subtract a bigger number. So we have natural log squared of 1 plus a minus 2 natural log of a, natural log of 1 plus a, plus natural log of a, natural log squared of a. Alright, and I have done that to get the following. Notice that in the parentheses we are left with natural log of a plus 1, or 1 plus a rather, minus natural log of a squared, which is obviously greater than 0. Alright, so notice that we have established 3 points at which the minimum can be attained. In every case, we have, in this case, we have something greater than 0. In this case, we have something greater than 0. And in this case, we have pi over 2. We have pi over 2. And only at pi over 2, we have this value of 0. Only there. So, this means that for every angle which is less than pi over 2, our function attains positive values, which is exactly what we wanted to prove. And this closes our problem. So, yeah, yes, very nice problem, I say. By the way, probably this is not the simplest solution. If you happen to know a better solution, please write a comment or something. And I will see you next time. Thank you very much for watching. Goodbye.